right, let's make a graph of the mass of solute that might dissolve versus the mass of solute added for a hypothetical solvent and solute. So we will be, with this graph, putting the dependent variable on the y-axis. Now the dependent variable, the y-axis, always goes in the beginning of the title, and then we say verse the independent variable, which is going to be on the x-axis. Yep. So the mass of solute dissolved goes on the y-axis. This is the the dependent variable. This depends on the amount of the independent variable that is added or that there is there. So, you know, the amount of solute that might dissolve depends on how much you actually add. If you don't add any solute, then none of it can dissolve. This depends on the amount of solute that's added. So the mass of the solute added is something that the experimenter can control. That is the independent variable. So it doesn't depend on a different variable. It's independent of other variables. All right, so let's go through a hypothetical scenario where we have a certain volume of water, maybe at a certain temperature, and we add 2 grams of solute. So they're added and they both are able to dissolve. All right, so graphing it, 2 grams of solute are added and 2 grams of solute are dissolved. So point right there. All right, we add more. We add 4 grams of solute. All of it dissolves. And then 6 grams of solute. All of it dissolves. All right, so graphing. 4, 4, 6, 6. And then we add 8 grams of solute, but only 4. Sorry, we add 8, but only 6 grams of solute dissolve. And then we add 10 grams, but only 6 grams of solute dissolve. I wonder what will happen next if we add 12 grams of solute. Only 6 will dissolve. 2, 4, 6. It seems that no matter how much solute we add, there's just a certain maximum amount of solute that can dissolve in that solvent at that temperature with that amount of solvent. So kind of graphing that, we end up with 8 grams, 6 dissolved, 10, 6 dissolved, 12, 6 dissolved. Yep, the amount of solute that is dissolved can't be increased from here for this amount of solvent. And so, kind of making that graph, line graph now, we can see that at this point we had a saturated solution. It had dissolved the maximum amount of solute for a given amount of solvent at a given temperature. This not only included the points where there was solid on the bottom, but this also includes the point where there is no visible solid on the bottom, but yet still the solution is dissolving the maximum amount of solute. So yes, there's solid visible here, but it's even saturated when there's no solid visible. All right, but in other cases where there was no solid visible and it had not yet reached equilibrium, not yet reached a saturated point, then those were unsaturated solutions. Those were basically not saturated. They were not full. They did not dissolve the maximum amount of solute for a given amount of solvent at a given temperature. So why do we reach this point of saturation? Well, if we have too much solute dissolved, then it will collide with and join up with some solid solute at a rate which is equal to the rate of that solid solute dissolving. So maybe in a given moment, in this case, a certain number of particles of solid solute dissolve. But at the same time, we have enough dissolved solute that we get equal amounts of particles crystallizing onto the solid solute at the same time. So we have equal rates of dissolving and crystallization. That is equilibrium. Equilibrium is when we have equal rates in the forward and reverse direction. That was visible when we were talking about vapor pressure. Remember when we had some liquid water at the bottom, maybe 3 particles might vaporize in a given moment, but also maybe 3 particles might condense in a given moment. So at that point, we cannot get any more gaseous water at that temperature in that sealed container. The amount of gaseous water is going to stay the same in that sealed container indefinitely. Similarly, you can't get any more dissolved solute at this temperature with this amount of solvent. No matter how long you stir it, you're dissolving the maximum amount of solute. All right, thanks for watching.